Welcome to Lesson 1 of the training package on integrated AADL analysis. This training package covers features of AADL and the FACE technical standard. These tutorials will touch on a variety of AADL analyses. The examples in this package illustrate the basic avionics lightweight source archetype, or Balsa. First, let's cover some prerequisites for completing this lesson. This lesson requires the open source AADL tool environment, or OSATE. Before using this lesson, you should download and install the latest OSATE release. You should also download the Balsa.face model that is referenced in this lesson. Finally, you will find it helpful to have a basic understanding of AADL and Balsa. In this lesson, you will become acquainted with OSATE, you will install and use the FACE data model to an AADL translator, and you will explore the translated Balsa AADL files. Let's begin with OSATE. For this training package, we'll assume a Microsoft Windows installation, but other platforms will operate similarly. First, find the OSATE executable on your file system and double-click to start OSATE. OSATE will open with several views. Along the left is the AADL Navigator where you manage your projects. In the middle is your model workspace. At the right is the outline view that illustrates the structure of the current model in the workspace. Along the bottom, OSATE logs errors, warnings, property values, and other attributes. Observe that we have already loaded the Balsa.face file in our file system. We have also created a new AADL project in which to perform the analyses called out in this training package. We named this new AADL project Balsa. Finally, we will drag the Balsa.face file into the new project so that we can translate it. Balsa is a working example of the FACE architecture. It is a simple avionics control system with 4 units of portability, or UOPs. Balsa has 3 platform-specific service segments: an EGI controller that outputs position and altitude, an aircraft config that outputs call sign and aircraft ID, and an ADSB communications output component. There is also a portable component segment called the ATC Manager that combines the outputs of the EGI and the aircraft config into information for the ADSB component. The Transport Services segment routes messages between the UOPs. Our next step is to translate this FACE model into AADL, but in order to do that, we need to install the FACE data model to AADL Translator plugin for OSATE. OSATE makes it straightforward to install supplementary components like the FACE translator. Under the Help menu, select Install Additional OSATE Components. Currently, there are 2 available. Select the FACE to AADL translator and follow the dialogues to complete the installation. OSATE will restart as part of the installation. To verify that you have installed the translator correctly, return to the Help menu and select About OSATE 2. View the installation details and confirm that the translator appears in the list of installed software. Now we can proceed to translate Balsa.face into AADL. Select Balsa.face in the AADL Navigator, then right-click. Select the option Translate to AADL from the menu. The translator will produce a folder in the Balsa project named model-gen that contains the 4 AADL files. Now let's take a closer look at the generated models. The Balsa UOPs are modeled as thread groups, each within their own process. As part of the next lesson, you will add properties and data flows to these models and perform timing and utilization analysis using the FastStar tool suite. But first, let's understand what each model contains. Balsa Data Model.aadl contains the Balsa data type declarations and implementations. Each data type declaration has FACE-specific properties that correspond to the FACE realization tier and the UUID. Balsa PCS.aadl and Balsa PSSS.aadl contain the thread group, thread, and process declarations and implementations for the 4 Balsa UOPs: ATC Manager, ADSB, AirConfig, and EGI. Each thread group contains a single empty thread with a period of 1 second by default. Balsa Integration Model.aadl contains the top-level integrated system. This system implementation has 8 subcomponents, 4 UOPs, a bus named UDP, and 3 abstract components. The transporter components are the equivalent of a face notion of a transport services segment, or TSS. The translator generates a transporter component for each interface between UOPs. We will use the implementation called Balsa Integration Model.impl for all of the analyses in this training package. Your last task for this lesson is to construct a diagram of this implementation. Right-click on the definition of the Balsa Integration Model.impl in the Model Workspace window and select Create Diagram. Name the diagram AutoGen and select Structure Diagram. OSATE will open a new tab in the Model Workspace containing the new diagram. While OSATE tries its best to draw a pretty diagram, it often needs help from you. You can change the sizes and locations of the diagram elements as necessary by clicking and dragging model elements. You can also export the diagram as an image for other purposes. Try to modify the diagram to look like the one shown here, and don't forget to save your work. This concludes Lesson 1 of the Integrated AADL Analysis Training Package.